Hi guys, welcome to Brainstorming Code, and in this video we are going to solve this question: remove duplicates from sorted array. So let's get started. So the question says that we are given an array, let's say 0 0 1 1 1 2. Okay, and we need to replace the duplicate elements such that the array should be 0 1 2 and rest elements should be anything. Okay, so we don't care about the rest elements, but there should be unique elements which should appear only once. Okay, so we can think of using a data structure here. So what we can do, we can store the elements, we can iterate the entire array one by one, and we can create an data structure where we will be storing the unique elements. Okay, so let's say we get first 0, so we put 0, then we get 0, but we know that 0 is already there. The data structure already knows that 0 is already there, so it won't enter 0 again. Then we add 1, then again we get 1, but it is already there in the data structure. Then again if we increment, we get 1, and we know that 1 is already there. Then again if we increment, we get 2, so we enter 2 here. Okay, so we have this data structure of size 3. Now what we can do is that we can get these elements and we can put these elements in the array itself again. Okay, so we can replace the first 3 elements of the array with these unique elements, and that's what the question says. We have to remove the duplicates in place. Okay, so we have to we have to modify the given array here. All right, so there is a data structure where it takes only the unique elements. The data structure is called as set, so we can use set here. Okay, so how are we going to do is, we are going to iterate each element of the array from 0 to n, and then we are going to enter all of these elements in the set. So what does set do is, it will only keep the unique elements from the array. Okay, so in this case what we do is, let's say my set name is unique dot add, and we will be entering the element. Okay, so in this for loop, the elements are inside the set. Okay, the unique elements. Now what we are going to do is, now we have the unique elements, we are going to again put those unique elements in the array back. Okay, so what we are going to do is, for number in the set, we are going to do to 0 and nums I plus plus number. Okay, and then it says that we need to return the unique elements, number of unique elements, so we need to return the size of the set. Okay, so the set contains the number of unique elements, so we can return that. Okay, this is the brute force approach, where the time complexity of iterating the entire array is O of n, and there might be, so in worst case there might be an array where all the elements are unique. So our set will be of size equal to array size. So the space complexity is also O of n. So here the space complexity and time complexity is O of n. Okay. So we went through the brute force approach of the question, and now we know that in brute force approach the time complexity is O of n and space complexity is O of n. So can we find a solution in O of n? Solution in time complexity O of n and space complexity O of 1. Can you find this? Okay, so let's try. So we are given an array 0 0 1 1 1 and 2, and here I can see that our array is sorted. Okay, so we can take that as an advantage here. So I can take 2 pointers here, I and j, where I is always less than j. Okay, so all the elements before ith element will be unique elements, and we will be using j for iterating from 1 to the end of the array. Okay, so here what we can do is we can check if I and j are equal or not. If they are not equal, we will increment j. Okay, and if they are equal, then what we can do is we will be incrementing I and will be copying the jth element to ith index. So what I mean here is, let's say, let me do a dry run here. So here first I is 0 and j is 1. So we can see 0 and 0, the both are equal, so we will increment j, so j will become 2. Okay, now I is 0 and j is 1, so we know that these are not equal, so again we will be incrementing I, and our array will be 0 1 1 1 1 and 2. So we copied the jth element to ith index. Okay, so this became 1 here, and now I is here and j is here. Okay, so again if I go down, we can see that our I is 1 and j is 2. Our I is 1 and j is 2. So now we again increment j is equals to 3, and we check that if I and j are equal or not. So yes, they are equal, so again we increment j, and we check that if they are equal or not. So yes, they are equal, so again we increment j, and here the j is at the end of the array, so we check if I and j are equal or not. So yes, they are not equal, so what we can do is we can increment I here, I is equals to 2, and we can copy the jth element to ith index here. Okay, so the new array will be 0 1 2 1 1 2, and I is here, j is here. So j comes here again, and we came out of the loop, and so now we return I plus 1. Okay, so these are number of unique elements in the array, and the starting part of the array contains the unique elements. Okay, and rest of the elements we don't care what they are. but it contains but the starting part contains the unique elements, and that's what the question says here. Okay, so this was the optimal approach of the question. And so let's calculate the time complexity here. So we are iterating through every element of the array only once, and we haven't taken any space here. I and j can be considered as constant space, so the time complexity here is O of n, and the space complexity here is O of 1. So let's code both of the solution, the brute force and the optimal solution. So now we will code the brute force approach first. So we knew that we will be using set in brute force approach, so let's define our set. So we are using a tree set because we want our elements to be in the same order as we are adding them in the set. Okay, so let's define the iteration variable for I is equals to 0, I is less than nums dot length I plus plus. Let's enter all the elements, or I can say let's enter unique elements from the array. And now now till here we have all of the unique elements in our set. So again we will be re-entering the elements, all of these unique elements in our given array. So for int element from set nums I plus plus is equals to element. Okay, so I is equals to 0. Again let's reinitialize I and return the size of the set here, which shows that we have these number of unique elements in the set. Okay, let's run this code. So we have passed the test cases here. Let's submit the code. And you can see that our code got submitted. Okay, so this takes O of n as space complexity and O of n as a time complexity here. So can we improve this code? Yes, we can improve this code. We have discussed the optimal solution, so let's code that optimal solution as well. So in our optimal approach, we discussed that we will be using 2 pointer here. So let's take those pointers. Int I is equals to 0 and j is equals to 1. Okay, so what we can do is, while j is less than array's length, so if ith element is not equal to jth element. Okay, so what we do here is we increment I and we copy the jth element to ith index, and if they are equal, so if this is not the case, so we will be incrementing our j, so we will be going to our next element. So let's return I plus 1 because this means that there are these number of unique elements in our array. Okay, let's run the code. So our solution got accepted. Let's submit the code. So yeah, our solution got accepted, and the time complexity here is O of n and the space complexity is O of 1. Okay, so thank you so much for watching.